So in our group, we were given the digital twin use case for the operation of the control cabinet. So very briefly again, because it was mentioned many times before. So what is a digital twin? It is a digital representation of an object which replaces time-consuming, expensive prototyping, and we can test different scenarios and interaction between different parts digitally, amongst many other things. So this allows us really to identify, for example, weak points and flaws in the design early on in the process. And digital twins allows us also to employ artificial intelligence and machine learning algorithms for example, condition monitoring, which allows us also to react more efficiently with appropriate solutions or actions. Next slide. So we settled on the use case of environmental monitoring of conditions surrounding a control cabinet. And this include, for example, heat, humidity, loss of power, amongst others. And we can use the digital twin there to optimize any kind of solutions according to the model. And my colleague will now walk us through the digitalization taxonomy and the different pattern types.
Digitalization taxonomy, according to what we have seen in the current use case Rittal, and the digital twins, which also involved in Industry 4.0, we have, I believe, a group of patents related to Rittal technology and process. And the first, we have the patent, no, excuse me, the first, his patent 10001613, which is related to data model that mention and describe the management of data collect with the process applied during of the manufacturing of product or equipment. This process allows the firm to handle the huge amount of data. Thus, with the logic control application is great tool for Rittal. And the second place, excuse me, I'm a little mistake. We have the patent EP125144, which is related with the preference model. It means that this technology enables the firm to manage the data for the equipment production in massive ways or with very specific detail. The last one is the patent DE102011, which makes it easy for the company to set the proper configuration of the components as for the machine box and the control cabinet as for John of technology equipment it produces. And the accurate optimization of command configuration, for example, is necessary due to the top-notch demand and standard the company must offer. And the next slide is Christine. Erika, no?
So it's me, thanks. So as mentioned, our use case is of a cabinet switch case environmental monitoring. Like humans, some components of switch cases work less well at higher temperatures or increased humidity. And so you can have significant savings and efficiencies if you can provide those electronic components in energy efficient environments, for example, a cool temperature environment. Thinking of the digitalization taxonomy, the noted European patent is considering input data, modeling, and then output, and the configuration of the components within the switch case. We can see that from the figure here that different operational states can be monitored, be it temperature or vibration, humidity, and then considered, and then the output can be to instruct a heat exchanger, a fan, or a cooling device, etc. So we see the movement from the physical world into the digital world, then back to the physical world. And by providing claims and patent applications to this use case, it allows us to obtain exclusivity into the customer benefit of improving productivity of switch cases in a variety of environmental conditions. Thanks.
The second patent is more about to provide control of cabinet, which is enabling the reliable data transfer in many different types of cabinets. Here, the main solution here is really separating the process into two major phases. The first phase is about the beginning of initiation, and there is a initial units, and somehow this initialization unit will transfer the enabling signal to the first direct sensors or actuator. It will maybe implied with a humidity sensor or the way or temperature sensor, and in the way around, it will transfer back the initialization data and to allow the initialization unit to make a decision to continue to the next step or just to terminate. So when all the criteria are met, so it will give the decision yes to start the non-initialization stage, and it will repeat the same logic once again by sending the enabling signal and getting back the initialization data and to store them just to actuate the other functions of the cabinet. So to summarize, the overall setup is just to provide the online monitoring of the whole system of the cabinet. Then I give floor to Erica to continue about this the third patent.
Okay, so I will be looking at another US patent, and it concerns a method for the provision of air conditioning in an IT environment, such as a switch cabinet, where there is an air circulation system to draw off the heat generated by the hardware and other components of the computation system. So it addresses the need to provide an air conditioning solution for an IT environment which reacts quickly to changes in the operating conditions. And if present, the proportion of free cooling is kept as high as possible in line with the recommendations of trade organizations. So the invention uses the cause of the temperature change for controlling the air conditioner, and the cause of a temperature change, that is the disturbance variable here, is the supply or drawing off of energy. So figure 6A and figure 6B, which are not very visible. Anyway, figure 6A shows the control loops to determine the fan rotation speed in the circulating air cooling system and the desired value of the feed air temperature. It also shows how the desired value of the feed air temperature is determined in the optimization process and influences the further feedback control. Whilst figure 6B shows the control loops, which ensure that an optimal air conditioning feedback control occurs. And in terms of taxonomy, these patents concern optimization, logic control, and input data model. Input data model and output. Christine will now explain in more detail.
Thanks, Erica. Can we go back a slide, please? There we go. So looking at the problems and the solutions that have been described, that are at least found in the patents that have been described previously. So looking at the first patent, which Russell described, the problem was really that known switchgear cabinets, they have air conditioning, but it can only be regulated to the volume of the cabinet. So adaptation to special functions was not possible. So it was only air conditioning and not more. So the solution really was to look, how can you monitor, how can you control, and how can you regulate what takes place then, but in accordance with predetermined programs. And they've done this with sensors, of course. So you've seen a lot of sensors and actuated, and they've added this, and the possibilities are really endless. You can say, look at humidity, door limit switches, vibration, smoke, current transformers, voltage transformers, code locks, and card readers. The second patent, Ching's patent, this was the problem there then became, well, if you've started to add so many of these, how are you going to put it all together? And so when you have a number of connected or connectable sensors, it's limited to a predefined number of terminals, the solution then becomes, you will need a control cabinet monitoring device with flexible possibilities for different applications and reliable data transfer. And you can do this with a direct connection sensors and direct actuators, which are not limited to a predetermined number of terminal sockets. So they should be able to be fixed or connected in a flexible manner. And you can use software, and it should be extendable. Then in Erica's patent, looking at IT environments in general, so the operation of the control cabinets really at the customer side, you're saying, well, air conditioning is probably the biggest user of current, and it accounts for 25% to 60% of the usage, and that translates into a huge energy bill for a customer. So if you can look at the solution and say, well, if you measure and define temperature ranges differently, you can have better control of them, and you can limit the amount of energy that is used in a rapidly, so that it reacts more rapidly, and in this way reduce your energy. So then looking at the patent types, it's summarized on the side there, but we've also located it. Can we move on to the next slide, please? So in this sense, we believe that all three patents can really be located in input, data model, and output. They can all be located there. Then the next patent is also to do with logic control, and I think that was Erica's patent. So you're looking at parameterization and weighting, how you can take the inputs and really closely monitor that to make sure that your outputs are correct. Then there were a number of patents also that related to configuration components and process steps, both in simulation and optimization. And this, of course, is really building on how you can then design your IP rights to cover your use case. The difficulty that we would have in this last stage almost of the value chain, but once it's in the hands of the customer, is that we cannot monitor how the customer is really using our own product unless we are physically in there. So that makes the use of digital twins very advantageous, because we can model before it gets into the hands of the customer how we would deal with that and develop solutions for them that they can use in their particular environment. Thank you very much.